Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we are going to learn how to factor quadratic functions. And if you recall from previous videos, a quadratic function is represented by ax squared plus bx plus c. And we had two big examples to show you how to factor quadratic functions. Let's go back to big example one and take a look at 3n squared minus 15n plus 18. And what we can do right here, we can factor out a 3. And let's just divide this whole function by 3. And so let's say we have 3n squared. We divide that by 3. Guess what? We get n squared or 1n squared because it's always like an invisible 1 in front of like a variable like that. But let's just leave it as n squared. And let's take 3 and we have a negative 15n. We divide that by 3 and that would give us a negative 5n here. And if we take 18 and divide that by 3, we would get a positive 6, and we could just park that 3 on the outside. And so now we have 3 times the quantity of n squared minus 5n plus 6. And so now what we're going to do now to find the zeros of this quadratic function, we're going to find two numbers that multiply to a positive 6, yet add to a negative 5. And those two numbers are a negative 2 and a negative 3. Because when I multiply those two numbers together, I will get that positive 6 right here. But yet when I add a negative 2 to a negative 3, I will get a negative 5 that you see right here. And those are the numbers we're going to use. We're going to use a negative 3 and a negative 2. And so now we have 3 times the quantity of n minus 3 times the quantity of n minus 2. And what we're going to do, we're just going to set these equal to 0, right? And so now we have n minus 3. We're going to set that equal to 0. We're going to do that first. And so if we add 3 to both sides, we will discover that n is equal to 3 because, see, uh, 3 minus 3 will give us that 0, right? So that's why it makes sense for n to be equal to 3, just like you see right here. And then we're going to do the same thing to this quantity of n minus 2, setting it equal to 0 by adding 2 to both sides. And as you can see, n is equal to 2, as you see it right here. All right. And so if you want to check it, you can always go back and distribute this 3 inside the parentheses that you see here, because see, 3 times n squared will give us 3n squared. 3 times a negative 5n will give us a negative 15n. And of course, 3 times 6 will give us a positive 18, just like you see at the very top. And noticing that our solutions are our zeros, okay? Right here, and remember our zeros or our roots will be at 2, comma 3 on the x-axis that you see right there. Those are kind of like called our zeros, solutions, and our roots. There it is right there for big example 1. So let's take a look at big example 2, in which we're going to factor completely 5x squared minus 55x plus 150. And what we can do, we can divide all these terms here by 5. All right, and so when we do that, so we have 5x squared divided by 5, that would give us 1x squared, or just x squared. And when we divide a negative 55x by 5, we will get a negative 11x. And then if we do the same thing by dividing 150 by 5, we will get a positive 30. And what we could do, we could think of it like this. What two numbers will give us a positive 30, and yet when we multiply them together, they give us a positive 30, yet when we add them together, it will give us a negative 11. And of course, those two numbers are a negative 6 and a negative 5, because a negative 6 times a negative 5 will give us a positive 30, while at the same time, a negative 6 plus a negative 5 will give us that negative 11 that you see right there. And so we're going to use a negative 6 and a negative 5. And we're going to put those into our parentheses, and we're going to take this x squared value. We're going to put an x here in this set of parentheses, while we put the other x in this set of parentheses, and we're going to put a minus 6 here and a minus 5 there. And what we're going to do, we're going to set everything equal to 0 to find our roots, right? To find our x-intercepts. And that is zeros again, our roots or x-intercepts. And so what we're going to do right here, since we have x minus 6, we're going to set that equal to 0. And so now we're going to find out what x is by adding 6 to both sides, and we will discover that x is equal to 6, because 6 minus 6 will give us that 0. And so now let us set x minus 5 is equal to 0, right? So we have x minus 5 equal to 0, and we're going to do the same thing by adding 5 to both sides and discovering that x is equal to 5, because 5 minus 5 will give us that 0. And so we know that our solutions right here, again, will be 5 and 6. And our solutions are the same as zeros, the same as roots, same as x-intercepts. Those are the terms that are associated with what we find right here on the x line when we create our parabola. And this is going to be a very narrow parabola right here because guess what? The a value is 5. So it's going to be a very elongated parabola that you see right there. And so if you want to check, we can go back and multiply all the terms by 5, and it will bring us right back to our original equation right here, our original uh, quadratic function equation. Okay, you have been given quite a bit of information. I wouldn't blame you if you need to pause the video to take a look at these two big examples, or replay this video as many times you need to gain a greater understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.